We're starting our new unit on triangle problems. So we're going to start off with our definitions of sine, cosine, and tangent that we already know. And we're going to redefine them using something that should be familiar from geometry, SOHCAHTOA. SOHCAHTOA could be used for any right triangle, so any triangle with a right angle. And this actually tells you what our sine, cosine, and tangent are. So this S stands for sine. And this tells you that sine is opposite over hypotenuse. The ca now, the C stands for cosine. And then you have A and H, which stands for adjacent over hypotenuse. And finally, the T stands for tangent, and O and A stand for opposite over adjacent. So SOHCAHTOA tells you which side of your triangle to use. So if this is my angle right here, my hypotenuse is always the side that's opposite the right angle. Opposite is the angle that's going to be opposite or across from this angle, so this is my opposite side. And then adjacent, which means next to, is the angle that's remaining, that's next to my angle. Okay, so let's look at problem number 1. We're going to solve for the missing parts. So right now we know that AB is 14, angle B is 25, so this is the angle I'm going to be using. The first thing I am going to do is actually find the measure of angle A, because this is the easiest thing to do, because we know that the three angles of a triangle should add up to be 180. So I know that the measure of angle A has to be 180 degrees minus these two angles, so this is 90 degrees and 25 degrees. So this is 180 minus 90 plus 20 gives me 115. And 180 minus 115 gives me 65. So I know that the measure of angle A is 65 degrees. That's my first missing part. Now I want to find what is the length of this side. So let's just call this side B, since it's across from angle B. And then this side down here, which we'll call A, since that's across from angle A. So this is where my SOHCAHTOA comes into play. So I know what my hypotenuse, which is 14. I'm trying to figure out B and A. So to find B, this is the side that is opposite 25. So I want to use the trig function that has opposite as well as hypotenuse, because I know my hypotenuse is 14. So for this one, I'm going to use sine, because it has opposite and hypotenuse. So I know sine of this angle right here, 25 degrees, equals opposite, which is B, over hypotenuse, which is 14. So now since I'm solving for B, I just need to get B by itself. So what I'm going to do is multiply by 14. And so I know that B is 14 sine of 25 degrees. So now to find this, I just need to put this into my calculator. I want to make sure that I am in degrees mode, because it's 25 degrees. So I'm going to go to mode, change my mode to degrees, second quit, and then do 14 sine of 25. And this gives me 5.91, and I'm going to round the third decimal point, so 5.917. And this is my B value. So now I'm going to do the same thing for A. Again, using the angle 25 degrees. A is now adjacent to this angle, and I can still use 14 for hypotenuse. So this time I'm going to use adjacent over hypotenuse, which is cosine. So cosine of 25 degrees is adjacent, which is A, over hypotenuse, which is 14. I'm going to do the same thing, solve for A. So A is 14 cosine of 25. Put that into my calculator, again making sure I'm in degrees mode, and that's going to give me 12.688, rounded to the third decimal point. And now I've solved for all my missing parts. I have 8B, the lengths of my sides, as well as angle A. So let's move on to a word problem. So this is the type of problem that we're going to be solving today, where you actually need to first read the problem to figure out what information is given to you, and then figure out which trig function to use. So number 2 reads, the altimeter of a jet approaching O'Hare Airport in Chicago reads 5,900 feet. Altimeter measures the altitude, or the height, of a jet. So if I know that the altitude is 5,900, I can already label the height here. This is 5,900. As it passes directly over the Sears Tower. At the same time, the angle of depression from the plane to the end of the runway is 5 degrees. How far is it from the base of the Sears Tower to the end of the runway? So I'm looking for this value right here, from the base to the end of the runway. And I know that my angle of depression is 5 degrees. So angle of depression means from here to here. So depression means I'm going down. This is 5 degrees. Luckily for us, we know that if this is 5 degrees, this angle right here is to be 5 degrees as well. So knowing that this is 5 degrees, now we can use these two. We're looking for x. Let's first figure out which of the trig functions we're going to use. So if this is my angle, my hypotenuse is this one right here. This is the opposite. This one's adjacent. So I'm looking for a trig function that connects the 5,900, because we know this number, with the x. So we want opposite and adjacent. So the one with opposite and adjacent is tangent. So we're going to be using tangent of 5 degrees equals opposite, which is 5,900, over adjacent, which is x. So now we're trying to solve for x. So in this problem, my x is at the bottom of the fraction, so I'm first going to multiply both sides by x to get it out of the denominator. This leaves me with x tangent of 5 equals 5,900. And now we're trying to get x by itself, so since these two are being multiplied, we're going to divide by tangent of 5 degrees. That's going to cancel out, so we're left with x is equal to 5,900 over tangent of 5 degrees. So now here, once we've solved for x, we can put this into our calculator, again making sure we're in degrees mode. 5,900 divided by tangent of 5 degrees. And this gives us 67,437 point, again 3 decimal points, 3, 0, and this 8 rounds up to a 9 because of the 5 after it. And since this is our, how far it is, this is distance, this is measured in feet. So here's my answer right here. One last example. So at 10 a.m. on April 26, 1998, a building 300 feet high casts a shadow that's 50 feet long. What is the angle of elevation? Okay, so let's first draw our triangle. We know the building's 300 feet high, so that's my height. And the shadow is 50 feet long. The shadow's on the ground, so that's this part. And we're looking for the angle of elevation, which is this angle right here. So that's what we're solving for. So looking at this triangle, the two numbers that we know, this is the one that's opposite this angle, this is the one that's adjacent. So we're again going to use the one that's opposite over adjacent, which is tangent. So tangent of this angle, which is unknown, so I'm just going to write it as theta, is opposite, which is 300, over adjacent, which is 50. And we can do 300 divided by 50, it's 6. And now to solve for theta, if you remember this, we're trying to find the angle. So what we're trying to do is undo my tangent. I'm trying to get rid of this tangent. And the opposite of tangent is inverse tangent. So what we're going to actually do here to find theta is inverse tangent, which is tangent, the little -1 there, of 6. Because really what we're doing is trying to cancel out the tangents. So in my calculator, that's second tangent, 6. This gives me my angle, which, because it's in degrees, we're going to just round to the nearest whole number. So this rounds up to 81 degrees. And that's my final answer. So whenever you're trying to solve for the angle, you're going to use the inverse or second button on your calculator.